Hello, this is Mr. Frisbee, and I wanted to record this review so you can have the chance to go over your test questions that you may have missed from the Chapter 1 test for Algebra 1. If you look at the screen, I wrote down what this is, and then if you look at the actual test results from the test, that would be located actually on this document here, and as you can see, question number 16 was the most frequently, but I actually threw that question out, so question number 16 is not going to be counted against you. But question number 21 is the first question that we'll go over, and that one actually 91% of the students in the class missed that question. Question number 7, 82% of the students in the class missed it. Question number 12, 82% missed it. Question 24, 82%. So as you can see, starting, the questions that are above 50% would be in this area, and those are the questions that we're going to go over. In fact, I'm going to go over all the ones that are 27% and above so that you can actually study the examples that I give you and retake the test and improve your grade. Alright, so I will go ahead and minimize this, and then what I'll do is start with a clean sheet of paper, and I'll go ahead and look up. Now we said we're going to start with question number 20, is that right? So when I need a review, question 21. Okay, then we'll go to the actual exam, which is located here, and question number 21, and let me go ahead and pause this for a second. Okay, so question number 21 actually on this test looks like this. It talks about the distributive property, and as I scroll through the test questions, I have to actually look at the question because some of the questions on this test, well, they're not actually numbered on this particular test, but once I get to it, okay, sorry about that. Here's question number 21. It says question 1, but it's actually question 21. Write 11, and that's times 47. And this is a copy of the test, so it's not written exactly the way it was on your original document, but it's 11 times 47 using the distributive property. So these were the possible answers, and so what I'm going to do is I'm going to go ahead and work this problem out and show you how to actually work it. So if I go back to here, it's 11 times 47 using the distributive property. What it's trying to get you to do, and we've gone over this in class, is to break up the second number into two numbers. Now there's multiple ways to do it, but there's only one correct answer on the test. And I could break up this 40 into 20 and 27, but for simplicity's sake, they're trying to get you to break it up so that you could multiply this in your head without using them, quickly. So if I was to multiply 11 times 40, if I break up the 40 into the 47 into 40 and 7, then I'm going to use the 11 and distribute the multiplication like so. And the reason why I chose the 40 and 7 is because 40 plus 7 is the same as 47, and it's easier for me to multiply 11 times 40 in my head than it is to multiply 11 times 47. So if I multiply this twice, and let me change the color on the ink, I'd multiply 11 times 40 and then 11 times 7, and I could do that in my head because I know that 11 times 40 would just be 11 times 4, which is 44, add a 0, and then 11 times 7 is 77. So if I add those two together in my head, you know, I can come up with, let's see, 517. Okay, so that's how you multiply that out, and that's what it's looking for. Distributive, just think you're going to have to break the number up and distribute it twice so that you can actually do these calculations actually in your head. Alright, thanks. Now to the next question, we're going to look and see what problem it was that we missed the most. And so if you look at problem 7, 82% of the class missed it. So let's go over that problem 7. So if I'm looking at problem 7, I'm going to go ahead and go back to the exam, and if you bear with me, I'll find it. Okay, this one's actually problem number 7, the one that says the temperature on the ground during a plane's takeoff was 4 degrees, and at 38,000 feet, the temperature outside was negative 38. Find the difference between the two temperatures. So to find the difference, that's the key word there, difference. You have to really read these things closely because there's key words which actually tell you what to do, and difference, the word, means subtraction. So you have to realize that it's asking for the difference, subtract. So you go back to write this down. Now, I'm not going to do the exact numbers that are given. I'm going to say, okay, let's pretend that the plane was at when it took off on the ground, let's say it was 25 degrees outside. But when it gets up to its altitude, really high up in the sky, it's going to be negative 50. So since it's asking the difference, I'm going to put minus because that's difference. And then it's actually a negative temperature when it gets up in the air that high. So now I have something that looks like this. And so since it's 25 minus a minus, we've talked about that you have two negatives, you have to change them both to positive, so it's actually turns out to 25 plus 50. The difference is actually 75 degrees when you do the calculations. So that is the little sign for degrees, 75 degrees difference, okay? Okay, for our next question, that was one of the frequently missed questions, that would be this one. It says write 9 as a power of the base 3. So it's saying write 9 as the power of base 3. So let's go over here and erase this page. It says write 9. So if I was asking you to write 27, as the base 3, well then you would have to know what the base is first of all. So I'm asking you to write that number, but you're going to use a base number. So if I say using base 3, then that base with what exponent would give me 27? Well, 3 times 3 is 9, and 9 times 3 is 27. So that's actually 3 to the third power. 3 to the third power gives me 27. So I got the number, this gives me 27, and I used a base of 3. So that's what it's asking for, but only a different number. Okay, so read it closely. Okay, this question's asking, question 24, frequently one of the most missed questions. Right here it says name the quadrant where this point -3, 2, and right here where you see this point, that is -3. Now, whatever it gives you first, right here, it gives you -3 first. That's the x value. The first number is the x, the second number is the y. Okay, there's always an x and a y. Can't write on this actual document. So if that's the x, -3, and that's the y too, you have to go in the x direction, and that's this line right here. This is the x. Okay, in the x direction, I want to go back 3, 1, 2, 3, and then in the y direction, I want to go up 2, 1, 2. Okay, that's how you get to that point. Back 3 in the x, and up 2 in the y, positive. That's there. There's a quadrant for this section of this area right here. There's a quadrant number for it. There's also a quadrant number here and here and here. So you just have to know what quadrant names there are. It's just like my name is David. You just have to know the name of it. But there is a reason for it. You actually start right here in this quadrant, and that's quadrant 1, the right upper quadrant. So if that's quadrant 1, then the one to the left of it, it goes counterclockwise. That's 2, 3, and 4. So you start in 1, then you go to 2, then you go to 3, then you go to 4. It's opposite of a clock, but it starts here. Okay, so if I ask you that point, I don't even need to go work it out on the other page, because you know, now if I asked you what quadrant this circle right here is in, that would actually be in quadrant what? 3, right? Okay. Alright, thanks. Problem 6 is actually this problem right here where I have my circle. This one. It says the highest temperature recorded in the town of Westgate this summer was 101. Last winter, the lowest temperature was -9. Find the difference between these two extremes. The key word here, that's what you have to look for in math, is the words, because the words mean what you're going to do with it, the operations. There's 4 operations, right? Addition, subtraction, multiplication, and division. Now, this right here, difference, means, again, the same as the other problem. So if you would have got one right, you probably would have got the other right, because they both have the word difference, which means subtract. Okay, so we're going to go ahead and work a problem that's like that. So again, both of these two problems are about the same thing. You're just going to go ahead and take the first number, like say if it was 200 degrees outside, and then you're going to take the difference, and so that means subtract, and let's say it was 200 degrees outside this morning, and tonight it cooled down to 150 degrees. Well, then you would just subtract, right? But what if it cooled down at night to 150 below 0, negative 150? Then you would have to remember, when you have difference means subtract minus a negative number, which is below 0 there, you're going to have to change them both to addition. So this becomes addition and this becomes addition. So now it's 200 plus 150 equals 350. That would be a difference of 350 degrees if it started at 200 this morning and went down to 150 below 0. That'd be a difference of 350. That's how to do that kind of a problem. All right. Alright, thank you. Welcome back. Here we go with the next problem. It's problem number 14 on the test, which is a frequently missed problem. It has a question about area, and it says the area of a square garden. Okay, and it says that the square garden has an area of, say, let's say 600, let's say 900 square feet. Let's say 905. Okay. Now, if the area inside this square garden is 905 feet, they want you to estimate the side length, the length of one of the sides. Estimate. Okay. Now, what do we know about squares? Well, hopefully, you know or you remember from your classes before that squares are equal on all sides. So that means to get the area, you're going to multiply two sides together or square one of them. So if all the sides are the same, let's just focus on what we're going to multiply times itself. Because if it's side, the length of a side squared, that gives you area of a circle or of a square, the A stands for area of a square, then what number times itself gives you 900. Now, we're estimating means getting close. Okay, so if I was to try 30 times 30, because it has to be the same number twice, right? They're all the same side. They're all the same length. Then would that give me 900? Yeah. So that would be close, and that's what we're looking for. So the answer that it would be looking for, if this were the actual problem, it's similar. I didn't give you the same numbers. Is 30. Okay. All right. Thanks. Okay, problem 25 on the test is one of the frequently missed questions. And problem 25, it says create a table, okay, of ordered pairs. This is what the problem says. You have to read these closely. Of ordered pairs. Okay. Now, to create a table of ordered pairs, and then it gives you an equation, or it's called a function, where you have y equals 2x squared minus 2. Now, in order to utilize this, you need to make a table. That's what it's asking for. Now, a t-table is what that looks like, and you're always going to have an x and a y. Okay. Now, remember again, just to remind you that if you had a number like, say, 3, 1, the first number is the x, and the second number is the y. That's your coordinates. Now, here it gives you the x's in the problem, and it said if the x value is -2, -1, 0, 1, and 2, what are the y's? So that's what you plug in to this equation to figure it out. See, if this says if x is -2, what is y? Well, the way to figure that out, to figure out what this is right here, what goes here, you have to put -2 where the x is. So I rewrite it. I write y equals 2 times -2, like that, squared. I've just replaced the x with a -2, minus 2. And so now I do my order of operations, so I get -2 times squared, which is -2 times -2, and that gives me 4, right? A negative times a negative. And then I still have this left. Now I multiply this out. Okay, and I get 8 minus 2. Just drop that down. So I get 6 here because 8 minus 2 is 6. So what goes here is a 6. Okay? So you can see if x is -2, y is 6. Now you plug it in with a -1 into this equation. Okay? So you're going to do this problem several times. Now y and then equals 2 in parentheses -1 squared minus 2. Now you do the same thing. -1 times -1 gives you 1 times 2 minus 2. This gives you 2 times 1 is 2 minus 2 is 0. So y equals 0. When x is -1, y is 0. Okay? Now what happens, okay, let me erase this. What happens when you put 0 in? That's the easiest. You love it when they give you coordinates with zeros because that's going to make it simple to calculate. Ones are pretty easy to work with too. Did you notice how easy that was when we worked with 1? Okay, y equals 2 in parentheses 0 squared minus 2, because 0 squared is just 0. 2 times 0 is just 0. Right here, 2 times 0. So 2 times 0 is 0 minus 2. Y equals 0 minus 2, which is y equals minus 2. Right? So minus 2. So this is the way that you get the ordered pairs. And then, once you figure out what all the ordered pairs are, okay, then you're going to go ahead and plot them in a coordinate graph that looks like this. Okay, so based on what I've just done, you should be able to finish for these two. Okay, then you're going to plot. So if I wanted to plot x is -2 and y is 6, remember the x line? Okay, if x, this is x, always side to side is the x, horizontal is the x, and then vertical, up and down, is the y. So if I'm going to graph this dot here, -2, 6, I got to go in the x direction, -2. That would be this way, 1, 2. Okay, 1, 2. Okay, so that's here. Then I got to go up in the y direction up 6. Okay, and so that'd be 1, 2, 3, 4, 5, 6. So back 2, up 6 is here. Now this is something you got to practice, but back 2, starting here, 0, 0, back 2, up 6. This dot right here is negative 2, comma 6. Okay? Now hopefully you can graph the rest of these on your own. And if you're having trouble, just watch this video again. And then you can always come and ask me for help later. Thank you. Alright, going back to the most frequently missed questions. You know, over half the class, 60% or more, miss this question. I'm going to show you right now, which is, well, let's just see. This is problem number 9 that we're going to go over. And 64% of the class missed this question. Now, this is a question that is just basic math. It's a general math question. So looks like we're a little rusty on fractions and just the general adding and subtracting of fractions and multiplication of fractions. So here's the actual problem. It says you've got 6 and 2/7 divided by 3/4. Okay, so if you watch closely, I'm going to demonstrate how to do this. You've got 6 and 2/7. I'm going to change this up. 6 and 5/8 divided by 11/12. Okay, so if I wanted to solve this problem, whenever you divide fractions, well, the first step you got to do is you always have to change any fractions before you multiply or divide. Now remember, the rules for multiplication and division of fraction are different than adding and subtracting. Okay, rules for division and multiplication of fractions are different than when you're adding and subtracting fractions. Okay, when you do these, adding and subtracting fractions, you have to have a common denominator. But when you multiply, you don't need a common denominator. When you divide, you don't need a common denominator. This is a critical key point you have to remember. Now, when I deal with this division of fractions here, the first thing that I'm going to do is look for any mixed numbers, and this is called a mixed number because there's a whole number right here and a fraction. You see, this is just a fraction here. There's no whole number. So in order to change a mixed number, which is a whole number and a fraction, to a regular fraction, or it's actually going to change to improper fraction, you always multiply these two numbers, the bottom and the one on the side, and you add the one on top. So multiply 8 times 6, that gives you 48. Add the 5, that gives you 52, right? No, 53. Okay, 53. So I have 53, and then the 8 stays on the bottom. Now, if I wanted to see, 53 over 8 is actually equal to 6 and 5/8. I can actually switch it back and forth. This is an improper fraction. Now, if I was to try to convert it back, I would just ask myself how many 8s are in 53 without going over, and that would be 6, right? And 6 times 8 is 48. That leaves 5. So 6 and 5/8 is actually equal. Okay, now divided by 11/12. So now, if I want to do the division, the best thing to do is change it to a multiplication problem. So to change it to multiplication, from the division to multiplication, all you have to do is actually take the reciprocal of this second fraction. You can only work, this only works on the second fraction. Reciprocal means you have to turn it upside down, you flip it over, okay? So 12 over 11, and then that's all you do to change it to a multiplication. From division to multiplication, you just flip it over, you take the reciprocal. Now it's 53 over 8. Just rewrite that. Now first, I could just multiply straight across and get the answer if I want. But it's better to go ahead and look to cross cancel. And so if I change the ink, okay, cross canceling means I could just look at the 53 and 11 and say, is there a number that divides into both 53 and 11? Is there a number that divides evenly into 8 and 12? Yes, 4 does. 4 divides into 8 and 12. So how many 4s in 8? How many 4s in 12? That can reduce to 2/3. Okay, because 4 divides into those. So now 53 times 3 is what? Well, 50, 50, 50, that's 150, and then add 3, 3, and 3. So this is an example of our distributive property, right? 50 times 3. I could write it 3 times 50 plus 3. That right here, 3 times 50 is 150. 3 times 3 is 9. So isn't it 150 plus 9, 159? Yes. And this is 2 times 11, 22. Okay, so I'm almost done. That is the correct answer, but this number on top is bigger than the bottom number. So it's an improper fraction. How many 22s are in 159 without going over? Well, let's see. 22 times 5, 22 times, I'm just guessing right now, I'm estimating in my head. 22 times 7, that might work because 20 times 7 is 140. So let's see, 22 times 7. Okay, now isn't that the same as 7 times 20 plus 2? Our distributive property again? Okay, so 140 plus 14 is what? 154. That's as close as we're going to get because that's close to 159. So you've got 7 and 154 minus 159 gives us 5 20 seconds. 7 and 5 20 seconds. Now, we love fractions and we know that they're a lot of work, but you know, if you just take the time to learn this and master this, it will never come back to haunt you and you can be a fraction master.